This is Saxon Algebra 1, Lesson 43. We're going to be finding the least common multiple, which is often written as LCM, least common multiple. And before we find that, we're first going to just review what is a multiple. So multiples are numbers that, for instance, if I start with a 4, the multiples of the number 4 are any number that 4 can be divided into evenly. So 4 can go into 4 one time, can go into 8 2 times, can go into 12 3 times. So if I keep adding 4, I can go infinitely into creating a long list of multiples of 4. So again, there's an infinite possibility. I just keep adding 4 each time to this long list of possible multiples. And if I do this for the number 5, I would start with 5, 10, 15, 20, 25, etc. And again, this could just go infinitely. Multiples of the number 8 include 8, 16, 24, 32, 40. And again, if I just keep adding 8 on each time, I could have this long list. So we can create these long sets of multiples, but when we want to take some numbers and find the least common multiple, we would want to find the multiple that they have in common that's the smallest possible one. So let me show you more about that. So if you're given a set of numbers that you want to find the least common multiple that those 3 numbers have in common, there's a couple ways to go about it. The hard way, which you will not do, so say you're given the numbers 18, 81, and 500. And you're asked to find what are the multiples, the least common multiple of each of these. So we could write our list, and this would take a really long time. So if we took 18, for example, and started listing out its multiples, we would add 18 each time and create this long list of numbers. Same for 81, 81, and then 81 times 2, I guess, is 162. So we could make this infinite list of each one. For 500, we would start with 500, 1,000, and we would have to go up pretty high to find a number because so far I'm not seeing that they have anything in common. So this would be a really painstaking way to find it, but you could go that way, but you would have to have a really long list. So Saxon has created a method to help you find it a simpler way. So I'm going to add a graphic here. So this is straight from the Saxon book. This reminds us that we call the smallest number that can be divided by each group of specified numbers the least common multiple of the specified numbers. So it's the smallest number that each of those can divide evenly into. And here's our process for finding that. We can find the least common multiple of some numbers by making mental calculations, but it's nice to have a procedure to follow. So here are their 2 steps. The first step is to write each number as a product of prime factors. So prime factors, prime talks about numbers that cannot be divided by any other number but itself and the number 1. So for instance, if I have the number 8, this is not prime because I can divide 8 by 2 and 4 to get 8. But a prime number like 7 can't be divided by any number except for 7 and 1. So the number itself times 1. So a prime factor means a prime number is a number you can get to, and it can't be divided by anything other than itself and the number 1. So we're going to use these same 3 numbers that we had up above, 18, 81, and 500. And we're going to use Saxon's method here and start by writing each as a product of its prime factors. So how I go about this is I make a little tree. And I'm going to start with 18, then we'll do 81, and then we'll do 500. So I make little branches off a tree, and I always have 2 branches to start with. And I pick 2 numbers that can go into it. And you can go kind of in any order because our tree will end up looking the same no matter which numbers we begin with. But we want to start with finding 2 numbers that can be multiplied together to get 18. So to start, I'm going to do 2 times 9. Once I'm at this point, I try to take each of those numbers and multiply them by 2 more numbers that get that number. But the number 2 cannot go any further. It is a prime number, meaning I could only branch it further of 2 times 1 to get that number. And again, once we're at that point, we know we've hit a prime number. There's no other numbers that can multiply together to get 2. But the 9 can go a little further. I'm still in eraser mode. I can multiply 3 times 3 to get 9. Now that I'm down to a 3, I can't go any further. The only thing that can multiply to get 3 is 3 times 1. So I'm going to circle each of these. So once I get to a place where you can't go any further and I'm at a prime number, I circle that number. So this helps us create our list. For the number 18, broken up into its prime factors, we have a 2, a 3, and another 3. So this is doing step number 1 up here. We wrote this number as a product of prime factors. So we're going to do that for our other numbers. So if I take 81, the first thing when I think of 81 is it reminds me that it's 9 times 9. And once I have my 9s, I know 9 can be 3 times 3. And at this point, I know these are prime numbers, so I'm going to circle them because that's as far as I can go. And this 9 broke into another 3 times 3. So to write my 81 as a set of prime factors, I would have 81 equals 3 times 3 times 3 times 3. And it's very important you include every single one. I know it just seems repetitive, but you need all 4 of those 3s to create that 81. So I have my list for 81. And now my 500, I'll start with 5 times 100. And then I say, can I break 5 down into anything smaller? And that could only be 5 times 1. So 5 is a prime number. So I'll circle it. I'm done with that branch of the tree. And my 100 can break into 10 times 10. I could have gone 50 times 2 and kept branching from there, and I'll end up getting the same results no matter which way I go. Now that I'm down to 10 times 10, I can break the 10 into 2 times 5. And this 10 can also be 2 times 5. And then when I look at each of those numbers individually, I realize 2 is prime, 5 is prime in both cases. So now, because I've circled these, I can't forget this 5 up here also. So when I write my list of prime factors that equal 500, I have 2 2s, 2 times 2, and then, so I just accounted for these 2 2s, and then I have 1, 2, 3 5s. So I have to make sure to include all 3. Can't leave any out. So now I have a list of my 3 numbers that I'm trying to find the least common multiple for, but now I have each one written out as a product of its prime factors. The next step, number 2 right here, is to compute our least common multiple using every factor of the given numbers as a factor of the least common multiple. And we have to use each factor the greatest number of times we see it appearing. So I'm going to scooch my screen down and write least common multiple. So here, you're just a detective going through and looking at each one and making sure you're accounting for every number and doing it the greatest number of times it appears in any one. So since 2 is one of them, I'm going to look here. There's a 2 here, and there's 2 2s over with the 500. So because it appears the greatest number of times, 2 times 2, I need to include 2 of them. When I look at my 3's, there are 2 here and 4 here. So I need to include the greatest number, so there were 4 with 81. So I need to do all 4. And the last one is my 5's. Since there are 3 5's in 500, even though there are none in the others, I have to include all 3 5's. So this is where you're allowed to take out your calculator and make sure you account for every single one. We're going to do 2 times 2 times 3 times 3 times 3 times 3 times 5 times 5 times 5. When you type that in a calculator and calculate it through, you come out with the number 40,500. That is the least common multiple of 18, 81, and 500. Again, if I had made my long list we were talking about up here, and we kept listing things out, we would end up getting 40,500 in each of these lists, but it would have been a crazy thing to do. That would have taken us hours, and that would have taken forever. So we go through this 2-step process of first creating our little prime factor tree, so we know the prime factors of each number, and then computing the least common multiple based on accounting for each prime factor and the greatest number of times we see it appearing in the numbers. So we're going to do one more example just to solidify this. It's another one from our book. We're going to do the numbers 30, 75, and 80. So we're going to do our factor trees and find our prime factors. 30 can break into 3 times 10. 3 is prime, so I'm done with this branch. 10 can factor into 2 times 5. And again, I'm going to circle each of these because these are my prime numbers. So 30 gave us 2 times 3 times 5. So we're done with our little list for 30. For 75, we can break this into 3 times 25. Our 3 is prime, so we're done here. And our 25 can break into 5 times 5. Since 5 is prime, we're done with these. So 75 gives us a list of 3 times 5 times 5. Our last one is 80. We'll break it down into 8 times 10 to start with. I could have started with 40 times 2, but again, it doesn't matter where you start. If you keep going down until you hit prime factors, you're going to get the same result. So the 8 can break down into 2 times 4. The 10 can break down into 2 times 5. So this 2 got us as far as we can go. But this 4 can break down into 2 times 2. So we're collecting a lot of 2's here. This 2 was the end of our branch, and this 5 is the end of a branch. So our 80 gives us 2 times 2 times 2 times 2 times a 5. So now we have these nice lists. So to create our least common multiple, we need to include 2's. There's 2's here. Because it appears the most in 80, we need to do all 4 that appear in 80. So now we've kind of accounted for our 2's. Our 3's, there's a 3 here and a 3 here. So there's only one 3 because it doesn't appear any more than 3 times or 1 time in each of them. And then our 5's, we have 1 here, 2 here, and 1 here. So because it appears the most 2 times, we'll include both of those. So our least common multiple will be 2 times 2 times 2 times 2 times 3 times 5 times 5. So again, this is where you're allowed to put it in a calculator, or you can calculate it long by hand. But if you put that in a calculator, you get 1,200. And that's our least common multiple. So again, let's look at our steps. Write each number as a set of prime factors, and then compute using every factor of the given numbers and the greatest number of times you see it in any of the numbers. So let me know if you guys have any questions about this or if you want some extra practice.